The first lecturer we have is Nils Rosmuller. I know him myself very well. 2 weeks ago we were in Riga with the FEU. Nils, welcome, and the floor is yours.
Thank you very much. Thank you. Not to, let's say, yeah, the emergency exits, you can see there. And in case of an emergency, you know how to go. We have first responders helping you to go to the right place in case of an emergency, but probably there won't be. Yes, as Dima told, 2 weeks ago, we met each other in the beautiful city of Riga, where the FEU had this program about the future of the fire services, fire and rescue services, and they asked me to present my insights dealing with the energy transition. And what I did there was I showed them some safety issues, and we discussed them with the delegates from all over Europe. And today I prepared a little bit different, because some of you might know me, some of you may know my key message, and we have, let's say, for a couple of years we tried to put emergency rescue services, fire safety on the public agenda regarding the energy transitions. And more or less, we think we do have it on the agenda. At least in this crowd, we have it on the agenda. But we need to make a next step. Not to have it on our own agendas, but to put it on others' agendas. So what I did to prepare this presentation, I raised some issues regarding energy transition and safety, and I made use of 3 databases that we prepared in order to have the facts and the figures, because we got a lot of questions. How often does it happen? It's only an example, it's anecdotal evidence, but yeah, we were sort of challenged to present facts and figures. So part of my presentations will be based on our own databases, presenting the facts and the figures. My name is Nils Rosmuller, working here at the Dutch National Institute for Public Safety as a lecturer, which is, and I see 2 of my colleague lecturers here, but in my opinion, this is the most beautiful job you can have in our organization. We do research, we educate, we write papers, we present our work, and there's no general director or someone who, let's say, tries to influence the conclusions and the recommendations. So we are pretty, let's say, independent in our way of working and concluding and putting things on the agenda. In my research group, which is 8 persons, we have people dealing with chemistry, physics, but also with policy and public administration. So we trying to understand what's going on in society, in Dutch society, in European society, and try to understand the physics, the chemistry behind the energy transition. Because, in my opinion, a big part of the energy transition is in hazardous material file. Many things that go along with the energy transition has to do with hazardous materials. So we try to have a sort of multidisciplinary bunch of colleagues dealing with energy transition. And when we need the knowledge from the fire and rescue services, I look at Ricardo, and we need the knowledge of fire safety engineering, we come to Liewe. And so that's the way how we try to, let's say, get more insights in what is happening with the energy transition in the Netherlands, and are we prepared to that, or what should be done to be prepared to that. So, a couple of highlights in my presentation. First, I will very briefly touch upon the built environment, because what do we understand? What is this built environment? Then I will touch upon the energy transition, in particular, what we in the Netherlands see in the energy transition, because our phase in the energy transition might be different from other countries or other parts in the world. We are now dealing with renewable energies, but there are continents in the world, they are trying to get rid of the old energies and try to make use of oil and gas, and we are trying to get rid of oil and gas and see where we can use wind, solar, hydrogen, LNG. So I will touch upon the Dutch situation. I bring some safety issues with them, and then we'll come to some facts and figures, because as I told you before, is it a problem? What's the problem? How big is the problem, to understand how relevant it is that we do research after the energy transition and safety, and we try to translate that research in standard operational procedures and guidelines and codes for safe buildings and safe operations of the fire and rescue services. And finally, I'll come to 2 or 3 major conclusions from my research and what I see. So first of all, something about the built environment. When Leo asked me, would you like to present your work in the context of the built environment? Of course, I would like to, but what is this built environment? So to make sure that we have a sort of same idea by what I mean, or what we use to use the term built environment for, I did some sort of Google research-like thing. And what I thought was, it's a sort of man-made environment where often man is cultivating land. We set buildings on it, we make infrastructure, production plants, warehouses. So the built environment is something that we sort of create ourselves. And we have all kind of varieties in the built environment. I've put some pictures on it, and for example, in the upper left corner, we see a future skyline of Rotterdam. This big building in the middle is photoshopped in the skyline of Rotterdam. And what you see in these big buildings, they are more and more relying on their own energy supply, and they try to store the energies in their buildings. We see car parks all over the place with charging points, battery electric vehicles, plug-in vehicles. So we see car parks not only parking our cars, but there's also sort of fuel station, which is not something that we were used to. We are very used to pedaling. We use e-bikes, we use e-scooters, we use e-steps. But when you follow the newspapers, you search the internet, you see all kinds of incidents go along with these light electric vehicles. We see the big data warehouses, the barns. Yesterday there was a big barn fire in the northern part of the country, although it had no solar panels on it, but we have also big fires with warehouses, barns, where the PV panels hindered the fire and rescue service activities, but also polluted the environment. And of course, we have the energy transition in the industrial areas. Of course, in the harbor of Rotterdam, hydrogen is not very new. Making use of hydrogen, they do this already for decades. But this hydrogen technology is in an increasing amount entering our society. We are doing pilot projects looking for hydrogen in residential areas. I just mentioned battery electric vehicles, but we're also looking at hydrogen, public transport, buses, vehicles. So we see this energy transition in the built environment, let's say, all over the place. And why is it that we sort of making work of the energy transition? It's, we have to take care of our planet. And even today, it's pretty hot for us, 25 degrees Celsius, and in the weekend it may become 30 degrees Celsius. And whether you're a believer or not, but our climate is changing. And in the Paris Agreement, they make the appointment with 197 countries that we should limit the temperature rise globally with maximum 1.5 degrees Celsius. So that means that we should get rid of the carbon dioxide emissions. So that means that of course, we should save energy. isolating our buildings, but also make use of other kinds of, let's say, clean or renewable energies. And that's what I sort of mean with the energy transition, making use of renewable energy to provide energy and thereby, let's say, reducing or eliminating the carbon dioxide emissions. Now, and what we see in the Netherlands, the focus is on sustainability, making use of clean or sort of green fuels. We produce energy using wind, using solar. We try to further electrify our society, and we produce the electricity needed for this electrification by developing a lot of solar fields, putting PV panels on our roofs, and wind turbines on sea, and of course also on land. And in the end, 2 years ago, our Dutch government also made the decision that we should put more effort on nuclear energy as well. So they made the decision to develop 2 nuclear plants, and they will be ready in 2035. So the point here is that there is no sort of unique energy source in the future that we are going to make use of. It will be a mix of all these kind of energy sources, and they all have their sort of specific safety issues go along with that. And that's important to recognize, because sometimes you might think, all right, we get rid of the fossil fuels, the gas, the gasoline, but they will be in place for decades along, and other energy systems, other energy sources will come along with them. So this is a nice picture. I think it's a nice picture from the top sector energy in the Netherlands, who's a sort of bunch of people who think about the future of the Dutch energy. And they prepared this slide, and you see in those orange circles the energy sources and energy carriers that they thought would be the future in the Netherlands. And they prepared this picture about 5 years ago. So you see liquefied natural gas at the left part. You see biomass, biogasification. You see hydrogen. You see green gas. But this was 5 years ago. And nowadays, 2023, we see other kinds of, let's say, energy sources, energy carriers come along. There's a big discussion going on in the Netherlands regarding ammonia. Ammonia is a nice, let's say, a nice substance that is able to have a lot of energy with it and to be efficiently be transported from A to B. But ammonia is also a toxic gas, and transporting large amounts of toxic gas from the Rotterdam harbor to the German hinterland makes that third-party safety along the railways, along the highways, is getting under pressure. We see a lot of PV panels. We see them on warehouses, we see them on lakes, we see them on acres, we see them on our own houses, we see them everywhere. But we also see the fires going along with them and the environmental aspects of those fires. We see the liquid organic hydrogen carriers, which is a substance which combines hydrogen with an energy carrier and then transport the energy from A to B. We see energy storage systems. We see them in our own cars, maybe, our own e-bikes, but also on industrial areas. We see them in skyscrapers. We see them on skyscrapers. We see them developing on events. In a couple of weeks, I go to a pop event, and it is a sort of green event, which means there are energy storage systems that provide the energy for the sound, for the lighting, for all the things that need energy. But we see also, it's not today, but in a couple of maybe decades, the small modular reactors, small nuclear plants, off the shelf, 1 megawatt, to be used for energy storage and reusable. And we see the urban heat networks. We use the heat from the industry in the Rotterdam Harbor to provide heat in our dwellings as well. And what's coming next, I don't know. But our, let's say, our sort of research mind says we have to put a lot of effort to get a good insight in what are the developments coming onto us. Because we as firefighters or fire safety engineers, we do not invent these kind of things, but we have to deal with it. And that's why we have to know what's coming next to us, and we have to sort of study the mechanisms that go along in order to understand the safety issues of these inventions. So for my, let's say, conclusion from this kind of inventory essay, we see renewable energy everywhere and all over the place, and we have to understand what's going on with that. So, to conclude this sort of introduction regarding the built environment and the energy transition, I've prepared some sort of overall overarching highlights. First, start with the situation as it was, let's say, 5 years ago. Fossil fuels and the safety risk. We know them, but they are still in place. But there's coming other systems as well. The PV panels, the hydrogen, the energy storage system, the electrification, the ammonia transport. So we're getting a sort of combined system of energy production, energy transport, energy storage. And we see that on every scale. On the continent, national, but also at my own roof. I have 18 PV panels on my roof. My neighbor had 14. And when we are on an anniversary in the neighborhood, we are talking about how much energy is it delivering right now. But no one is talking about the safety aspects of those systems. And when I enter my street and I look at my roof, I don't see those panels. But when the firefighters have to fight a fire, for example, in my house, are they aware of these kind of systems on my roof, the conjunction box, the cables to the central box for electricity? So they are facing all kind of new, let's say, risk in their jobs. And other risk, I said I had 18, he had 14. There was a period with the storm in February last year. I had still 18 after the storm, and he had only 10. So it's not only the electricity part that we have to deal with, but also the, let's say, the physics, the wind. 4 of the panels of him blown away. 3 we found them back. The 4th one still. Probably someone could use it, but you should imagine 80 centimeters by 120 centimeters, 25 kilograms, blown away into the street. So we are facing additional risk in these kind of systems. And another risk, when we talk about producing energy, selling energy, storing energy, we ourselves are becoming more and more our own sort of energy companies. And people have to deal with these kind of new interrelationships with each other. And the point here is that becoming a sort of energy company in the future might give some new issues, because there's a sort of congestion on the energy network. So who has the right to deliver back, or who has the right to sell those stuff? And then in my own neighborhood, I had some students in my class, and I gave them a sort of assignment, get your bike or your car and see what's going on in your neighborhood dealing with the energy transition. And I live in the province of South Holland, which is the western part of the country, and one of the students came back with these kind of pictures. At the upper left, we see a small industrial area where they are developing renewable energies and thinking of developing a microgrid. So they develop their own energy and could be very, let's say, autonomous from the national grid as well. So produce themselves, store themselves, and sort of be independent from the national network. Of course, we see electric charging, we see the wind turbines, but we also see initiatives to use hydrogen in our houses, and we see hydrogen cars. So when you, let's say, you walk through your villages, your cities, probably it doesn't cost you a lot of effort to see what's all going on with the energy transition in your own environment. But the thing is, you are the ones who are, let's say, specialized in safety. So what kind of safety mechanisms go along with these kind of developments? And when I look at those developments, I say, whoa, we know a lot of hydrogen, we know a lot of electricity, but more in a sort of industrial domain. And now more and more these kind of industrial technologies enter our own neighborhoods, our own houses. So we bring the risk closer to the citizens, to me, to you. And we are no safety operators. We don't have safety management systems. We are just using, and probably sometimes we are not using our systems in a very sophisticated way as well. When I look in my neighborhood and I see 4 or 5 e-scooters packed on each other, when I see e-bikes crushed all over the place, there's only one conclusion that I can make. This doesn't go well. And that's our own behavior. We are sometimes sort of unaware of what we are doing with the systems that we are using, with the technology that's brought into our houses. So a lot of effort in the future, in my opinion, should be put on awareness. Create awareness with the people that use the new renewable energy systems. And that's even more important because when we look at the city of The Hague, where our government is and where legislation is being developed, legislation is always behind innovation and development. But in this field, in the energy transition, it's even more because the developments are in a very, very high speed. And it's almost impossible to get a grip of what's going on in this renewable energy transition. But making guidelines and codes takes a lot of time and takes a lot of, let's say, also decisive power to do so. Because we have big ministries, infrastructure, economic affairs, who are pushing the energy transition to their limits. And when you raise your finger and say, how about those homemade energy storage systems? Where should you position them in your house? What kind of safety measures should you take? It takes a long time before these kind of answers are being questioned and put into codes and regulations. So we see a lot of developments, a lot of parties involved, interdependencies, and what does that mean for your work as a fire safety engineer or fire and rescue service worker? What we did is we studied a lot with a lot of people the couple of years, but the headline is that we studied the risk and the measures to prevent those renewable energy risks. We looked at the third-party risk, the environmental risk, and we also prepared standard operational procedures for fire and rescue services. And it would take far too much time to touch upon all these three, but you can all download them from our site. But what I will do is I will touch upon the risk assessment, and I will use the data that we have, let's say, gathered the last years regarding PV panel fires, battery electric vehicles, and light electric vehicles to put some numbers on the problem. We made this overview of renewable energies and the risk, and I use this overview, and I will not touch upon all these issues, but I will go into the solar and I will go into the energy storage systems. And for example, the last one, sustainable construction materials. I saw some presentations and workshops in this event that deal with wooden buildings and making use of natural materials. So this is addressed in a couple of workshops here. But let's go to the solar energy. We see those big, because the upper right picture, we see those big farms, those big solar fields developing in an increasing speed. And we also see the risks that go along with those PV panels. Fires, and it's not the PV panels that burn themselves very well, but installing them has some risk, we have seen. Electrocution, blown away, deposition of small silicium parts of the cells in the environment. And we also have seen mechanisms that, because of the high voltages of the cables, in case they run parallel to steel pipelines, they deteriorate the cathodic protection of those steel pipelines. So some of the risks are really good visible, and some of the risks we sort of see because we understand the mechanisms of what is going on. And when I see and I look at those PV panels, of course we see them on the acres. When I drive from Delft to Arnhem, I see some acres with PV panels, hundreds of them. We see them in lakes, we see them on the big barns, we see them on our own roofs, and we see them in a variety on our roofs. We see them on the roof, but we also see in-roof systems. And this is, I will come back to those on versus in-roof systems in the next slide. But we also don't see them. The picture in the right lower corner, these are all PV panels. And just like I said, when I have a fire in my home and we have these PV panels on the roof you don't see, this doesn't seem like a sort of energy production facility, but it is. And we have to take care of those PV panels as well, in particular in the future, because we want to have those PV panels on our roofs, in our walls, but are we aware that they are? Regarding the on-roof and in-roof, here we have a fire. It was in Vinkenveen a couple of years ago. It was an in-roof system. And what you see here is that the neighborhood, the people didn't live there. It was only installed, and it got on fire. There was an installation error. And what you see here is that the in-roof panels have been positioned in one big line all over the roof. So the fire barriers in the houses might work, but the fire spreads on the roof to the next. Yeah. PV panels don't burn a lot, and probably Roy and Niels will touch upon in their workshops as well. But they hinder the fire and rescue service activities. And they might be the cause of the fire. And we have seen fires in electricity substations. We have seen fires on data warehouses. We've seen fires on warehouses themselves. We see fires because of those PV panels in an increasing amount in the Netherlands. So some figures. The Dutch Energy Research Center and Applied Research Organization, TNO, they gathered some data about those fires. And what they found out was, whoa, we do see those fires In what amount? Oh, 2018, we are sort of starting up the PV panels in that year. They get grip of 24 fires in 2018, and surprisingly or not, but 20 of them were in our own private environment, and 4 were on, let's say, offices and warehouses. But more important was the finding that 80 to 90% of those fires, in case they were able to, let's say, get a grip on what kind of system it was, dealt with in-roof systems. 80 to 90%. And then what were the causes? It's always easy to say it was a sort of human error, but sort of improper installing. The electricity was for 70% of those fires were the cause. The installers on the roof, they did not connect connector A with connector A. The wires were too loosely laid on the roof, so they moved. Or in some ways, they were too tired, so they were cut. Regarding the in-roof systems, they had too less space between the panels and the roof, so the heat below the panels became very high. And in case they had not used the proper fire-resistant material below the panels, it got on fire. So a big issue with new technology is also educate the people who have to do the work. So before these kind of fires got more common, there was this guideline, and it said, you have one guy or woman in your organization who has a little bit, let's say, knowledge about safe installing these systems. But this person on, let's say, on the office is not the one who goes on a roof and install them. So we have to make sure that those people who make things, they have the right knowledge, and they are facilitated in a better way than we are used to. And now we have more and more inspection schemes. Scope 12 is one of the schemes that is to be used for, let's say, is this system installed in a proper way? All right, you have all kinds of checklists, and of course checklists are also just a way of dealing with issues, but when you use these checklists or you let them used by a professional, you can be ahead of a lot of problems with fire and solar panels. But we have also other issues with solar panels, which is the deposition of those small, sharp parts, silicium, in the environment. And a couple of months ago, we had some pretty big fires. One was in Etteleur, a city in the southern part of the country, and one was in Sint-Oederode, also in the southern part of our country. And these are pictures how it looks like, and what happens with these kind of fires is the panels, they burst, small parts of silicium, they get into the air because of the high temperatures of the smoke, and they are carried with the wind into the environment. And then you have them on your acres, where farmers have to hold their animals, their crops, and sometimes in neighborhoods where people are doing their work or children playing. And that's an issue that come along with these new kind of energy systems as well. It's not only the fire, but also the sort of worries when the fire ends, what is in the environment. And probably Roy and Niels will touch upon what comes along with these kind of fires, from maybe also a toxic point of view. But when we saw these kind of depositions of sharp added pieces, we're thinking, how is it about the responsibilities for these sharp pieces? Who's responsible for putting them away? And in the beginning, the government, the local municipality was looking at the owner, and the owner at the branch, and the branch at the fire brigade. But now we are so more or less, hey, we should get rid of the stuff. The municipality takes the responsibility to appoint a company, get rid of the stuff, and then the bill is being paid by all the insurances of the owner. How about the numbers? We have sort of gathered information about those PV panel fires and the deposition. Last year's 2018 until 2021, which is 4 years, we had 112 fires, at least ones that we gathered. And we saw in about 9 to 10% we saw deposition. And this deposition, as we saw the estimates of the fire safety regions and the municipalities, they range from a couple of kilometers to 10 kilometers. So those sharp edged pieces, they come pretty much into the environment. And they cover a couple of square kilometers. So in the beginning, when we addressed this issue, they said, what are you talking about? Is it once a year? Is it 10 meters? Is it 20 meters? Is it 50 meters? And now we know 10% of these big fires, they cause deposition and they cover a big area near these fires. Going to the energy storage, because producing energy with wind turbines and with PV panels is important, but probably you're not able to use it directly, so you have to store it, and sometimes you have to transport the energy. And the big issue with lithium-ion energy storage is the thermal runaway. Probably you know the sort of self-evolving mechanism that the fire continues, even when you might think we are having it under control, it might raise its temperature and then it ignites the next cells in the battery packs, and so you get the thermal runaway. And the thermal runaway, it's a big issue for fire and rescue services for a couple of reasons. First of all, stopping it is hardly possible, but there are also some pretty dangerous mechanisms go along. In particular in the case when these thermal runaway mechanisms are in a confined area. A lot of gas is being produced, and when this is come under pressure and it gets its oxygen by opening a door, it might come to an explosion. And we have seen those explosions. We have seen them in Arizona. I think we have seen this mechanism also in this small ship in the harbor of somewhere in Friesland. I think there was this battery pack in the lower parts of the ships, and then getting oxygen to the fire, and this pressure gulf pushed away the firemen. So we see these incidents, and we should learn from them. So what could we learn from them? First of all, we see those energy storage systems all over the place. On roofs, on squares. This is the municipality of Delft, where we see energy storage systems on the squares as well. We see them on construction sites. We see them on the pavements. This is what's in it. So seeing them is pretty easy told, but sometimes we don't see them because they are there. And we are not aware that they are in place. And when we are not aware, we might experience these kind of fires. This was, the first call was, we have a fire in a bike shop. The first call. But there's not so, in a bike shop was fire. But in the end, there were 6,000 e-bike batteries burning here. We have seen fires in parking garage. And we have a lot of issues dealing with parking garage fires in themselves, but the issues become even more complex when EV cars are involved, because the thermal runaway is very difficult to suppress. So all kind of technologies and new inventions have been used to, let's say, to get the car out of the garage. But what's next? Who's responsible for the car? Who's going to pay for keeping it cool? Who's going to pay for the contaminated suppression water? New kind of issues dealing with car fires. And of course, we have also the light electric vehicles. And we've all seen the bans of these vehicles in the bigger cities, for example, in New York, in London, in the subways. You are not allowed to get your e-steps, e-bikes, e-scooters in the subways. And that's not because we don't like them there, but they are a very big fire risk in those systems. And again, we got the question, what's the risk, how often? So my colleague Tom, he prepared a database, and we tried to get a sort of grip on the number of fires. And we started this database from 2021, and we made a lot of use of our colleagues in the safety regions to get the data to us, which is a hell of a job, and we are, day by day, we are really grateful for them that they are willing to help us with gathering the data. But what we see for the year 22 is about 300 fires with alternative fuel vehicles, which also could be compressed natural gas, but let's say 95% of them deal with plug-in hybrids and battery electric vehicles. And what we see next is that 1/3 of them, the battery pack is involved in the fire. And when the battery pack is involved in the fire, then we are sort of alert of, and how is it with the thermal runaway? And we got the data back from our firemen and women on the scene, and we see that this moment of the thermal runaway, when it is started or when it is becoming aware, in almost the half of it, or half of it, the thermal runaway is already in place when the fire and rescue services are becoming on the accident scene. So with a couple of 8 to 10 minutes, the thermal runaway already started. Then the light electric vehicles. A couple of weeks ago, I met some people from the fire department of New York, San Diego, and Seattle, and this light electric vehicles is their main safety concern. The fires at the 37th floor in New York, people dealing with charging their e-bikes next to the door, repairing e-bikes, getting another battery pack on the e-bike to extend their axis radius. This is their main sort of focus point regarding safety in their built environment. And what we see from our light electric vehicle database, we see an increase in these fires. We see an increase in e-scooters, we see an increase in e-bikes, so it's more or less sort of logic that we also see an increase in the fires. And the fire of an e-bike, let's say, in a park or in a garden, is not a big issue. But in a house, it is a big issue, because a lot of energy is in these batteries, and within seconds, your room could be full with toxic and flammable smoke. 40% of these fires we see from our data set are inside shops, inside houses, inside garage. And 90% deal with e-bikes and e-scooters. So, to come to the end of my presentation, what does all this brings us? We are facing a nice future, because renewable energies, taking care of our planet, is a very good, let's say, transition that we are facing. But we look at the safety perspective of these things, and we see the risk being, let's say, new. We need new standard operation procedures. We do have them in our sort of brief booklet. It's in English, it's on our website. But the most, let's say, the most important thing is that we might all be aware of the safety risk, but we should make a sort of direction to the ones who are responsible for these risks as well. And let's say we should pay maximum attention to prevent those risks and to take the knowledge that we have to translate them in codes. And we should put our emphasis also on the ones who are responsible. So the designers, the original equipment manufacturers, the spatial planners, they deal with these risks. And they should not say pass a risk to the fire and rescue service, which is something I hear when I talk to these kind of companies. But they should use your knowledge as fire safety engineers, as fire and rescue services, to understand the risk and to make sure that the proper measures are being taken. And finally, we ourselves, our behavior and the behavior of your neighbors is also key in making a safe energy transition. And that's my final words for you. And if there are any questions, please feel free to pose them to me.
Any questions? Don't be shy.
I have a question. It's for the battery.
I'm the racing reporter, so I'll come to you.
Thanks for your presentation. I have a question about the battery electric vehicle. Is there also a comparison made to the internal combustion engine, the amount of fires?
We didn't make them. And there are a couple of reasons for that. We know the number of car fires in the Netherlands, and we know the number of battery electric vehicle fires. So that's, we can compare our numbers. The funny thing is that right now, what is the sort of exposure measure in which you express the fires? Is it the vehicle kilometers? Is it the years that they are in case? And the other thing is why we did not make this comparison is that the internal combustion engine, they are in our society for 20, 30, 40 years. Those cars, they exist for a very long time. And now we are seeing that those battery electric vehicles, they are getting to some of them are getting to their sort of end of life. So this sort of aging issue is not in the data set right now. So that's why we are not very keen of comparing those two types of vehicles. But what we see from US research, from Norwegian research, is that the car fires with battery electric vehicles and internal combustion engine vehicles, it's not that there are more car fires with electric vehicles. So that's, as we see it right now from big studies from the US and Scandinavia, there is no reason for sort of wariness from the number of car fires. Okay.
What do you think about cooperation with insurance companies? Because the private domain is often excluded from the legislation, and there are good reasons for it. But you show that the main problems occurs in the private domain in the future. So maybe a cooperation would be nice.
Yes, and maybe it's all in the word cooperation, because we join forces with some of the insurance companies to gather data, to understand the issue. And they use it for their premises and what kind of, what is their sort of earning potential. And we use it for understanding the safety mechanism as well. So sharing data is, for us, it's key as a research institute. But for society, it's key to have the proper advice from people working at those companies. When, for example, we had this big speed skating stadium in the Netherlands, you know, Tialf, where they had those solar panels on the roof, but they got off because of safety issues, and they were addressed by the insurance company. So this is also a mechanism that could add to a more safe energy transition as well. And our cooperation as an institute is try to get their data to us, because they have a lot of data, but they are not very keen on sharing data. There are a couple of insurance companies that have their data. It's also sort of competition between them. And sometimes the data are sort of, privacy. It's difficult, but we try to let's say, exchange data sets.
Any other questions? Over there. And over there.
Thank you, Nils, for your very interesting presentation. I have a question regarding the fact that, we realize that, built environment and all the devices we use, they have so many new risks, but it's very hard to mainly bring this risk outside the built environment, because otherwise we have to start banning all these systems. So I was wondering, is prevention a good strategy? Because we sort of have to accept that we can have a higher chance of, fire ignition or fires in our built environment. So maybe we should just focus on developing, strategies and make robust fire safety measures, fire safety strategy to be actually ready for these events.
Yes, if I do understand you well, you say it's not possible to prevent, so make robust strategies how to deal with them. Is it that sort of? Yes, that would not be my sort of cup of coffee. No, the thing is, big companies are making big money with their products. And they could also spend money on inherent safe products. And they could also, let's say, take the responsibility when something goes wrong with those battery electric vehicles, for example. And a lot of money comes along when the fire has been extinguished, and then who takes care of the contaminated water? Who takes care of the car? And in my opinion, there should be more incentives for OEMs to develop and design safer products, taking care of our behavior, because our behavior is not that good as well. But when you know that people smash their e-steps and e-bikes all over the place, because that's the way how it is, then we have to sort of rethink our design and think, what does that mean for the integrity of those battery packs? Instead of, this is the battery pack, as small as possible, with the highest energy capacity per kilogram. So this is what we put in our e-bikes. I'm sort of ambassador of putting the responsibility more in front of the production, instead of developing robust strategies how to deal with them. Because I think that's not what we may expect from our firefighters, because they are facing the risks. And the others are making money out of the risks.
Thank you for your presentation, Nils. In line with the two other questions, what's your advice to the government concerning the legislation as an independent institute? What should the government do?
What do governments do? Nothing.
It starts with listening, not to us, but listening to what's going on. And then the processes to develop codes and guidelines and legislation, it takes years and years and years. And the energy transition takes days and days and days. So I think we should speed up the way we develop codes. And sometimes it's better to have a code for 80% that works well than develop a code that works for 100% and takes 5 years, and then we see new kind of developments and innovations have entered the market, and the problem may be already solving itself. So my sort of key notice would be recognize that with these developments, risks come along, and weigh those risks, and those risks that you think are unacceptable, make a sort of commitment within half a year or something like that. We have an 80% working code or guideline. That's pretty easy said from a researcher point of view, I know, but you asked me for a sort of advice.
Okay. Anybody else? Then we're all up to coffee. Niels, thank you very much.
Welcome.
We have a short break at 11:30. I suggest that everybody is back in this room, and then the next speaker, Wojciech Gryński, he's doing the next session. So have a nice cup of coffee. 11:30, we start the program again. Thank you very much.